Hello guys, hello grade 12s. We are now preparing for May, June paper 2 exam. Just tell me how you wrote your paper 1. Hopefully you wrote your paper 1 very well. So now we are talking about paper 2. I want us, the first thing that we go for is Euclidean geometry. Euclidean geometry will be there with a lot of marks, obviously. So we need to know our Euclidean geometry very well. So let's go through Euclidean geometry and see what they bring. This is a pre-June exam Euclidean geometry question. Okay, so let's read the information of question 8. They are saying in the diagram, PQRS is a cyclic quadrilateral. Let me annotate. PQRS is a cyclic quadrilateral. So you need to remember the theorems of a cyclic quad. Please remember the theorems of a cyclic quad, because cyclic quadrilateral will obviously be there in your exam. So you need to remember your theorems very well. PQRS is a cyclic quad. ST is a tangent to the circle at S. So let us look at ST. Let us look at ST. ST is tangent to the circle at S. This is my ST. This line, it is tangent to the circle at S. Okay. So once they give you tangent, guys, you have to look out for what we call a tan-cot theorem. And tan-cot theorem is, the examiner loves it so much. So once they give you tangent, what must you do? You start looking for what we call the tan-cot theorem. You check on your diagram whether the tan-cot theorem will work when we solve the problem. So I have a tangent ST. I have to identify the chord which is in contact with the tangent, the chord which is meeting with tangent. In this case, I will draw a chord from S. I'll say my chord is this one in this time around. And then the angle 42, remember S1 they are saying is 42. This angle 42 is what we call the angle between the tangent and the chord. That 42 is the angle between the tangent and the chord. If you look at the angle, yes, it is formed by the tangent and the chord. Remember, when two lines meet, they form an angle. So which lines are meeting? Let me raise and show you the lines that are meeting. The line ST, or you can say TS, this is the line of tangency, meet with the line of RS. They meet, they form an angle S1, which is 42 degrees. So this angle, which is between the tangent and the chord, is equals to the angle in the other segment. The angle between the tangent and the chord is equals to the angle in the other segment. So I'm going to give you a tip on how to find the angle which is equal to the angle between the tangent and the chord. Or how do we find the angle which is in the other segment? Do this, grade 12. Subtend your chord. What is my chord this time around? It's SR. So I'm going to use the chord SR to find the angle which is equal to this one. So we subtend the chord SR. So if we draw, this is S, this is R. If we draw a line from S and a line from R, we notice that those two lines, they meet at the angle P2. So we say the angle P2 is subtended by the chord SR. Therefore, we say S1 equals to P2. Our reason is tan chord. Here, please, guys, make sure that you study your tan chord theorem. So since S1 is 42, therefore P2 is 42. So you need to understand your tan chord theorem. I think I should not rush when I'm dealing with this idea of tan chord theorem. I will also, let me do this. Let me say we have got a second. I want to explain this idea of tan chord because most grade 12 learners, they struggle with tan chord. So let's say we have got a line which touch the circle only at one point. We know that this line, it is called tangent because it's the line which touch the circle at one point. Now we can draw a line which we call a chord. So watch carefully, this angle here is between the tangent and the chord. And we say the angle between the tangent and the chord is always equals to the angle in the other segment. How do we find that angle in the other segment? Subtend your chord. Use your chord to find the angle in the other segment. Let's say my chord is AB. So I will check the line which comes from A and another line coming from B. Those two lines, they must meet at the circumference. Okay, let me do this. So I will say if this is X, even this one is X, you tan chord theorem. Please know you tan chord theorem. Okay, then as we continue, I think as we read we were told about tangent. It's important to read your information, guys. Make sure that you read your information. We are also told that PQ equals to QR. That is shown on the diagram. PQ equals to QR. It is shown. S1 is 42. S2 is 108. I think we can now read the question. And let me give you advice. The Euclidean geometry, for sure, most of the time in your final exam in November, there are 4 questions of Euclidean geometry. The first 2, they are simple, they are not difficult. So please make sure that question 8 and 9, you get those 2 questions right. Maybe if you are struggling, struggle with the last question of Euclidean. The first 2 will be simple. So don't even be afraid. Just know that the first 2 questions are doable. So now let's answer this problem. We are looking for Q. Determine with reason the size of the following angles. So the first angle that we are looking for is Q. Let me do this. Okay, determine with reason the size of the following angle Q. I'm trying to pick a pen. Let me pick this one. Okay, we are looking for the angle Q, and we know that this shape here is a cyclic chord. This shape is a cyclic chord. And we know that opposite angles of a cyclic chord are supplementary. So S2 and Q, they are supplementary. Opposite angles of a cyclic chord are supplementary, meaning that those opposite angles, they add to 180 degrees. So when we take S2 plus the angle Q, which we are looking for, they must give us 180. And we should not forget to write the reason. Please write the reason. Opposite angles of a cyclic quad are supplementary. You write your reason. Now you know that S2 is 108. 108 plus Q is 180. Therefore, Q is 72. We take 108 to the right-hand side. 180 minus 108 is 72. So you found your angle Q, so easy. You found your angle Q so easy. Your Q is 72. Now, the next question on 8.2 says, find R2. Find R2. Expect a triangle which is called isosceles triangle in your exam. I've never seen Euclidean geometry questions without an isosceles triangle. They love this isosceles triangle so much. So if you look at the triangle Q, P, R, this triangle QPR is an isosceles triangle. We know that isosceles triangle has got two sides that are equal, and it also has got two angles that are equal. So since we see that QR is equals to QP, we are going to call this side, we normally say this is our base side. And then now the angles that we find on the base side, these two angles P1, the angle base side, P1 and R2, they are equal. It's simple to identify two angles that are equal in an isosceles triangle. Let's say you have got a triangle like this one, and we say this is an isosceles. Maybe we say A, B equals to AC. It means this BC is our base side. And the angles seated here on the base side, they are equal. Okay? So it's very easy to identify angles that are equal in an isosceles triangle. And you must be able to do that. You must be able to see two angles that are equal in the isosceles triangle. Another way of seeing two angles that are equal, you can do this. You can ask yourself, let's go back to the triangle QPR. You ask yourself, which angle is opposite to the side QR? You see that angle is P1. And you say, which angle is opposite to the side PQ? You see that angle is R2. You now say, therefore, P1 and R2 are equal. P1 equals to R2. The reason is what? These are the angles opposite equal sides. This is the reason that they want. You say angles opposite to equal sides. So two angles that are opposite to two sides that are equal, they are also equal. So isosceles triangle carry two sides that are equal. It also carries two angles that are equal. Now in this diagram, in triangle QPR, we see that P1 equals to R2, and they want us to calculate R2. So what we're going to do, we're going to say, okay, angle Q plus angle P1 plus angle R2 is equals to 180. This is the sum of angles in a triangle. When we add all angles in a triangle, we must get 180. We know that Q is 72. We know that P1 it's equivalent to R2. So I can substitute P1 with R2. R2 equals to 180. Now I'm going to take 72 to the right-hand side. So I'm going to have 2R2. If you add R2 with R2, you get 2R2. So 2R2 is equals to, you take 72 to the other side. You transpose 72. So you're going to have 180 minus 72, which is 108. Now you divide both sides by 2. You have 2R2 equals to 108. You divide both sides by 2. You have 54. Which means that the angle R2 is 54. Even the angle P1 is 54. Okay, so you found the R2. You now have to find the P3. Yes, they're looking for the angle P, or P2, sorry, P2. They're looking for the angle P2. They're looking for the angle P2, which is this angle, this side. P2 is this angle. So how do we find the angle P2? Oh, this one actually I already solved it, guys. I said to you, S1 equals to P2 according to the tan-quad theorem. Remember, this line ST is tangent, and then the line SR is a chord. So this angle 42 is the angle between the tangent and the chord. And we know that the angle between tangent and the chord is equal to the angle in the other segment. How do you find that angle in the other segment? I said use your chord. I told you the chord in this case is SR. So you subtend your chord SR. You make use of the chord SR. So you draw a line from S, another line from R, you meet at P2. So you notice that the angle S1 is equals to P2. Tan-quad is your reason. Therefore, P2 is 42. So you found the value of P2. So now I have to find R3. Do I even have R3? Oh yes, I have to find R3. So I found P2 to be 42. Okay, I found P2 to be 42. And P1, if you remember, we said it's 54. Okay, now look. This Q, P, S, R is a cyclic quad. This shape is a cyclic quad. So you have to remember the theorems of a cyclic quad. This is a cyclic quad. And if you look at the angle R3, this angle that they are looking for here, R3 is the exterior angle of a cyclic quad. So is the angle outside my cyclic quad, so this R3, and we know that the exterior angle of a cyclic quad is equal to the opposite interior angle. The angle outside is equal to the angle inside. The angle outside the cyclic quad is equal to the angle inside. So you say R free is equals to this angle inside, which is 96, which is 54 plus 42, which is 96. So R3 is 96. And guys, let me say this. If we give you a circle and we give you a quadrilateral where all vertex are at the circumference of the circle, where all vertex, this quadrilateral has got 4 vertex, 1, 2, 3, 4. All vertex are at the end of a circle, are at the circumference of a circle. It means that this shape is a cyclic quad. Even if they don't tell you in the exam, you have to see that this is a cyclic quad because all vertex are at the circumference of a circle. Now, what happens when we produce one of the line of a cyclic quad? It's more like we extend a line. Let me extend a line BC. BC. So who extended the line BC? You are forming the angle outside. You are cyclic quad. This angle outside here, we call it the exterior. And what do we know about this exterior angle? It equals to the opposite angle, which is inside. So we see that C is opposite to A. So we say this exterior angle is equals to this interior angle, which is A. This is the theorem that says exterior angle of a cyclic quad is equals to the opposite interior angle. So that's how I found R3 here, that is 96. Because the angle outside is equal to the angle inside. Okay. And you cannot pick 54, you pick the whole angle 96. Okay, we found R3. So now what can we are done with this question. I told you, there will be a simple Euclidean geometry question. So this is where now you have to accept. When we bring the simple Euclidean geometry question, please make sure that you collect marks there. So what is it that you have to watch out? Watch out. From this question, we notice that let us not rush into moving. We need to watch out. We need to watch out for a cyclic quadrilateral. Note the theorems. Note that the opposite angles h to 180. Note that the exterior angle of a cyclic quad is equals to the opposite interior angle. And another thing which is important, watch out for isosceles triangle. Note that isosceles triangle has got two sides that are equal. It will also have two angles that are equal. Watch out for that isosceles triangle. Okay. Now here on question 9, there is what we call proportionality theorem, which I believe you really need to watch out for prop theorem. Prop theorem will be there. Obviously, they will bring it in your final exam. Proportionality theorem will be there. We also hopefully believe that it will be there in your June exam. It's one of the important theorems as much as we are talking about grade 12 stuff. So I will, for now, leave prop theorem a bit. I will come back to this problem of proportionality theorem. Question 10, one of your questions in Euclidean geometry, it will be a question of a proof. So you have to prove those, you have to know how to prove those different theorems. Here they want you to prove that angle at the center, it is twice the one at the circumference. So you can watch, I did post a video where I was proving that angle at the center, it is twice the one at the circumference. You can check on my YouTube channel a video where I was proving this theorem. So let's leave this one off a proof because it's already there. If you check on my channel, you will find it. I want us to look at the problem of 10.2. It's very important that you read the information. In the diagram, O is the center of a circle. Okay. O is the center of a circle. Let us look at that center of a circle, O. It's here. Now, let me give you my advice. Let me give you my advice. Once they give you the center of a circle, look out for what we call equality. So if you look at the line from O to P, this line is a radius because it's a line from the center of a circle to the circumference at P. So this is a radius. And we have got another radius OQ. This is another radius. So please, when they give you the center, watch out for those equality. So OP equals to OQ. Then from there, you identify that we have what we call isosceles triangle. The triangle OPQ become an isosceles triangle because it will be a triangle which has got two sides that are equal. OP and OQ are equal. So the triangle OPQ is isosceles. It has got the two sides that are equal, which automatically makes P1 and Q3 to be equal. Remember, I said isosceles triangle has got two sides that are equal and two angles that are equal. Okay, so that's it about the center. Watch out for equality. And whenever they give you the center, again, you must also watch out for what we call a diameter. I have to explain this one, even though I think here a diameter is not there. The theorem of diameter won't work here. But I have to explain to you guys. Once they give you a center, look out for the diameter. So let me say I do something like this. Let me say I give you a circle and I give you a straight line passing at M. And I say to you, M is the center of a circle, which means that automatically the line AB is your diameter. Now, from the diameter, watch out for the angle which is 90 degrees because the angle subtended by the diameter is always 90 degrees, or we call it the angle in the semicircle. So watch out for the angle in the semicircle. So you've got the diameter AB. Now I'm going to create an angle which is subtended by the diameter AB, meaning that I will form an angle whereby the line comes from A, another line comes from B, they meet at C. So this angle here is 90 degrees. We call it angle subtended by diameter, or you can say angle in the semicircle. Watch out for this diameter guy. So here we are given the center, but we don't have a diameter. Now, another thing that we have to look out for whenever we are given the center is this theorem that says angle at the center, it is twice the angle at the circumference of a circle. So let us check if this theorem is going to work. So the first thing that I want you to do when you are applying the theorem, angle at the center is twice the angle at the circumference. I want you, grade 12, to do this. The first thing that you do, you look out for what subtends this angle at the center. You need to be exposed to the language of Euclidean geometry. You have to understand what do we mean when we say subtend. So I'm saying you have to check what subtend that angle at the center. So the angle at the center here on our question is this angle O. What subtends this angle? We simply observe carefully where does these two lines that form angle O come from. So we are going to observe now. We say, oh, this line comes from P, and the circumference, it comes from P, and this other line comes from Q. So we say, okay, this angle at the center O, it is subtended by PQ. We now go and look for an angle at the circumference, which is also subtended by PQ. Remember, angle at the center and angle at the circumference, they must be subtended by the same chord. In this case, our chord is PQ, or one can say must be subtended by the same arc. So let us look for the angle at the circumference, which is also subtended by PQ. Because here, this angle at the center is subtended by PQ. You look for the angle which is also subtended by PQ. So that angle is actually S1. If you look at the lines, these two lines that form the angle S1, this line comes from P. This line comes from Q. So we say, oh, this angle O, it is twice angle S1. The reason is angle at the center, it is twice the angle at the circumference of a second. So we are analyzing the information. We are interpreting. So O is twice C1. Angle at the center is twice the angle at the circumference. So let us continue now observing. Okay, what else? They said O is the center of a second. PQ equals to QS. We are told that PQ equals to QS. That is indicated by this line. Okay. QRS is Y. This is indicated. This angle is Y. The tangent at P, remember, I told you that whenever they give you the tangent, look for what we call tan-cot theorem. But this time around, I will also say to you, whenever they give you tangent, check if you have this theorem as well, which is called tangent is perpendicular to the radius. Tangent is perpendicular to the radius of a second. So they are saying the line PT, it is tangent. So let us show the tangent line. This is tangent. Now, you look for the radius which touch the tangent. I want to see the tangent and the radius being in contact. They must have a point where they meet, tangent and the radius. So we have this radius OP. So I have a tangent meeting with a radius OP at P. Now at the point of contact, tangent and the radius, they form 90 degrees. Why? Because tangent is perpendicular to the radius. This is a theorem in Euclidean geometry, which you must know grade 12. Tangent is perpendicular to the radius. So which means this angle here is 90 degrees. Because tangent and the radius are perpendicular to each other. Okay? And another thing about tangent, I just want to teach. Actually, here I'm teaching, guys. I'm trying all my best to deal with this Euclidean geometry on your behalf. I want you guys to start excelling in Euclidean geometry, because once you excel in Euclidean geometry, you will do well in your next paper too. Euclidean is covering a lot of marks. So it's one of the topics which we need to watch out for very, very, very carefully. So another thing that I want us to observe regarding tangent is the theorem that says tangents drawn from the same point are equal. Okay? Yes, I know some of you are saying, sir, can you please start answering the question? But in order for us to answer the question, we must be strong with our background knowledge. So I'm laying the foundation of Euclidean geometry. I want even someone who is starting Euclidean geometry for the first time to be able to learn and master the ideas, the theorems of Euclidean geometry. So I want to remind you of this theorem. Tangents drawn from the same point are equal. It is not here on this question paper, it is not here, but it might come in your tune exam, it might come in your final exam. We have to talk about it. So let's say we have got a line which touches the circle at one point. And we have got another line which touches the circle again at one point. And these two lines, they meet. They are both straight lines. This line is tangent. Let me say maybe at A. This line also, it is tangent at R. So let me call this point where the two tangents meet, let me just call it a set. So what now we say is that ZA is equals to ZR. Why do we say ZA equals to ZR? We say this because we see that these two tangents, they come from the same point. They come from the point Z. So ZA equals to ZR. These are the two tangents that they come from the same point. And then if now I draw a line from A to R, what you guys need to know now is that this angle here is equal to this angle here. Remember, I told you, watch out for isosceles triangle. It means that the triangle ZAR is an isosceles. Why? Because the line ZA and ZR are equal. So I said, whenever we've got two sides that are equal, that is isosceles. We know that if two sides are equal, we also have two angles that are equal. So you have to watch out for those two angles that are equal. In this case, it's angle A and angle R. Remember, A is opposite to set R. R is opposite to set A. So these two angles are equal because they are opposite to two sides that are equal. Okay, so watch out for tangent. Watch out for tangent is perpendicular to radius. Watch out for tangent drawn from the same point. Tan-Cot theorem, you must always look out for it. So let us check for the Tan-Cot theorem on this question paper. Remember they said to us PT is tangent. So this is my tangent. Now I have to observe my chord. I have to look for a line which is chord. In this case, my chord is PQ, which means that this angle P3 is equals to the angle in the other segment. What must you do to find the angle P3, which is in the other segment? I said, use your chord. Substantiate your chord. You will know which angle is equal to P3. So now I see that my chord is PQ. So I will draw the line from P to Q, or I will move along the line from P, I won't create my own line. I will use the lines which are here. I will look at the line from P and also the line from Q. Those two lines, they must meet at the circumference of a circle. So if you look at the line from P and another line from Q, they meet at the circumference at a point S. So we say S1 and P3, they are equal. P3 is equals to S1. What is the reason? Tan Cot theorem. Tan Cot theorem. S1 equals to P3. And in the exam room, just to, in case you don't forget, I know that you guys, you go with highlighters. You can even do this. You can start highlighting and say, I know that this P3 is equals to S1, so that you don't forget those angles that are equal. So highlight those angles so that you will remember, oh, my P3 and S1 are equal. It's possible that you can forget. So please highlight, highlight, highlight. Grade 12. Give a reason why P2 is equals to Y. Now we start answering the question. After the interpretation, give a reason why P2 is equals to Y. Let's check. Okay. P2, why is P2 equals to Y and it's 1 mark? Oh, this is one of the theorem that says equal chords subtend equal angle at the circumference of a circle. So if I give you a circle and I give you a chord AB, this chord AB subtends the angle C. Okay, now let me give you another chord. Let me say it's chord DE. And this chord DE subtends the angle F. Now, if I say to you, these chords are equal, if I say AB is equals to DE, automatically the angle C and the angle F will become equal. Angles subtended by equal chords at the circumference of a circle, they are also equal. So let us look. This chord PQ is equals to chord QS. So when you see two chords that are equal, you look for the angle subtended by those two equal chords. So which angle is subtended by PQ? We see that it's S1. I said the angle must be at the circumference. So S1 is subtended by PQ. Which angle is subtended by chord QS? It's angle R. So the angle Y and the angle P and the angle S1, they are equal. Yes, this is what I see. The angle Y and the angle S1, they are equal. These are the angles subtended by equal chords. Y and S1 are equal. So I see that Y is equals to S1. And I know that again, if we check carefully there, I said P2 and S1, they are equal. So why? This is an isosceles triangle. I said watch out for isosceles. This is isosceles. Which means, remember I said PQ equals to QS. So this PQS is isosceles. You can think of this side as a base side, which means that the angle P2 and the angle S1, they are equal. So we set S1 equals to Y. Also P2, will also be equals to y. So what is the reason why P2 is equals to y? And yeah, I'm a bad mathematician. I'm taking a long try. Actually, there is a better reason why P2 is equals to y. There is a better reason. These are the angles subtended by the same chord or angle at the same segment. Yes, angle in the same segment, angle subtended by the same chord. And this is one of the theorems that you can never write Euclidean geometry and you don't need it. Okay, so when we approach 10.2.1, we're going to talk about angles in the same segment, angles subtended by the same chord. What subtends the what is subtended by the chord QS? Which angle is subtended by chord QS? You see that if you draw a line from Q, you draw a line from S, you meet at R. So the angle R is subtended by the chord QS. And there is another angle which is subtended by the same chord QS. Which angle is that? Is the angle PQ. So if you draw a line from Q and draw a line from S, you see that the angle PQ is subtended by the chord QS. Now you say, okay, the angle P2 is equals to y. What is the reason? Angles in the same segment. Angles subtended by the same chord. So P2 is equals to y, and also Q2 here, or Q2 plus Q3 is equals to S2. So P2 equals to y. What is the reason? Angles in the same segment. Angle in the same segment. Yes. I thought we will use a reason 10.2.1. I thought we will use a reason that says equal chord subtend equal angle. So that is not the one. Angle subtended by the same segment. Okay, now the question says prove that PQ bisects TPS. Actually, prove that TQ bisects the angle P in triangle TPS. Remember, if we write this way, if we say TPS and we put something like an asterisk here, we are saying focus on angle P in triangle TPS. Put your focus on angle P in triangle TPS. So let us look at this angle P in triangle TPS. So I'm going to firstly identify the triangle TPS. TPS. This is the triangle TPS. Now they are saying, prove that 10.2.2, prove that PQ bisects the angle TPS. So this line PQ, they are saying we must prove that it bisects the angle TPS. What is to bisect? To bisect is to divide equally. So they are saying, prove that the line PQ divides the angle P equal. So it means that they are saying, show us that P3 is equals to P2. That's what they are saying. And watch out for this one. This one can come anytime. Watch out for the line that bisects the angle. So they can say to you, prove that this line PQ, go and divide the angle equal. So this time around, if the angle is divided equal, if this angle here is divided equal, it means P3 is equals to P2. So let us prove that P3 equals to P2. Okay? What we know already, we know that P2 is Y. So for us to prove that P3 equals to P2, we have to show that even P3 is Y. So what do we know about P3? Very important. You want to show that P3 equals to P2. You start gathering information about those angles. P2, we know from 10.2.1 that P2 is Y. So I have to find a way of showing that P3 also is Y. So I'm gathering information about P3. I say I know that P3 is equals to S1. P3 equals to S1. Why so? Why do you say so, say? Because the line PT is tangent. The line PT is tangent. And if you observe carefully, the line PQ is a chord. So I told you that the angle between the tangent and the chord, which is P3, is equal to the angle in the other segment. And I said to find the angle at the other segment, use that same chord. So if we subtend the chord PQ, we notice that if we draw a line from P and draw a line from Q, remember we must meet at the circumference. We must go to the circumference. So P3 is equal to S1. That's what we know about P3. P3 is equal to S1. Now I've gathered information about P3. I know that P3 is S1. Now I have to start gathering information about S1. We know that P3 equals to S1. So any other angle which will be equivalent to S1 will also be equivalent to P3. If for example, we find that S1 is equal to angle R, we'll say that P3 also is equal to R. So let us get information about S1. Now S1, we notice that it's equals to angle R. It's important to give a reason. Here it is a term chord. Why is S1 equals to angle R? I talked about this. I said equal chord, subtend equal angles. So the angles which are subtended by chords that are equal, they will also be equal. So let us look for those chords. Let us look for those chords. We have a chord PQ and we have a chord QS. And we see that the chord PQ is equal to the chord QS. So we look for the angles which are subtended by this chord. So which angle is subtended by this chord? S1, it is subtended by PQ. And then angle R is subtended by QS. We look for the angles subtended by these two chords. So we say, oh, S1 and Y, they are S1 and R. Remember, this angle R is Y. So which means that S1 is equals to Y. Now, because S1 equals to Y, it means that even P3 is equals to Y. Remember, we said P3 is equals to S1. We said P3 is equals to S1. And we just found recently that S1 is Y. So it means that even P3 is Y. Okay? Now, because P3 is Y and P2 is Y, PQ did bisect the angle TPS. Remember, we wanted to prove that P3 and P2 are equal. They are both equals to Y. So the line PQ bisect the angle P, which is in a triangle TPS. It means that PQ bisect the angle TPS. So that was 4 marks. I love the question of 10.2.2. Practice it carefully. Okay, now they say determine POQ. Determine POQ. So let's check which, they are looking for angle O in triangle POQ. They are looking for the angle at the center. They're looking for the angle at the center in terms of y. And we know that angle O, it is twice S1. I told you that the angle at the center, it is twice the angle at the circumference. What is subtending this angle at the center O? It's PQ. So you look for the angle which is also subtended by PQ. Remember, guys, don't forget this. Angle at the center, it is only twice the one at the circumference if they are subtended by the same chord. In this case, what subtend angle O? It's PQ. Look at this line that comes from O. Level A. If we think about the angle O created by this line and this line, where does this line come from? Come from P. Where does this line come from? Come from Q. So the angle O is subtended by PQ. So what you do, you have to look for the angle which is another angle which is subtended by PQ. And that angle must be at the circumference. So we look for the angle subtended by PQ. I'll move from P, move from Q. I see that that angle is S1. So that is why we say the angle O, which is at the center, it is twice the one at the circumference. Now, it means that angle O is going to be 2y. Remember, the angle S1 we said is y. It's actually important to write on your diagram so that you don't forget that we said this S1 is y. Even P3 we said it's y. Even P2 we said it's y. Now we are saying angle O is 2y. Because the angle at the center, it is twice the angle at the circumference. Okay, now we are going to prove that PT is tangent to the circle passing through P, O, and A. So I'm going to create that invisible circle that they are talking about. They are saying the circle pass at P, pass at O, passes at A, and come back and touch P. I'm trying to create the invisible circle. Yes, I can. There's no way I can be accurate, but I want you to have a picture of the circle they are talking about. Maybe let me erase this other thing so that you can see what I'm trying to do. I'm talking about the circle moving from O, touching A. Let me try to create a better circle. Touch at P. Yes, it's the circle that is passing at POA, A here. And they are saying, prove that the line PT, am I right? Yes. Prove that the line PT, it is tangent to this circle. So it's very important to identify the chord of this invisible circle, which will also touch my red line, which I'm thinking of it as tangent. So my chord in this case is this line PA. If indeed there is a circle passing at POA, my chord will be PA. which means that the angle between the tangent and the chord will be this P3 plus P2. And don't forget that P3 is Y, P2 is also Y. So this angle here is 2Y. And then we know that the angle between the tangent and the chord must be equal to the angle in the other segment. And I said use the same chord to find the angle in the other segment. So in this case, I'm seeing PA as my chord. So I have to look at the angle which is in the other segment. So I draw a line from P, boom, O, draw a line from A, boom, O. And I know that this angle is 2Y. So which makes sense that the line PT is in this tangent, because think about it. The angle between the tangent and the chord is equal to the angle in the other segment. So because these two angles are equal, we say PT is tangent. So when you answer this one, you say TPA is equals to 2Y, and we know that O is equals to 2Y. You actually say TPA is equals to O. They are all equals to 2Y. Then you say, therefore, PT is tangent. What is your reason? You say converse of a tan chord theorem. Okay. Prove that the angle A in triangle OAP is 90. I'm going to raise everything. This is an interesting question. Okay, prove that, what is the question? Let's do the question. Prove that OAP is 90. OAP is 90. So let's do this. Prove that OAP is 90. So they are saying focus on angle A on triangle OAP. So let us see this triangle OAP. Okay. So they are saying prove that this angle here is 90 degrees. This question is very, very, very interesting. Very interesting. So I want to prove that the angle here is 90 degrees. Okay? This angle OAP, that angle will be 90 if the line PA is equals to the line AS. The line PA, guys, illegally the line AS. If we find that PA is equals to AS, then this angle OAP will be 90. I'm looking at theorem number 1 of Euclidean geometry that says a line from the center of a circle to the chord perpendicular to chord bisect the chord. So I think here they are testing the converse of such theorem. So let's say we have got a circle and we have a chord AB. And we have got a center. So we've got a line coming from the center to this chord AB. If AM is equals to MB, automatically this angle here becomes 90 degrees. This is the converse of theorem number 1. A line from the center of a circle, if it's perpendicular to chord, will bisect the chord. So this one, I won't be surprised if I see this theorem being tested. Theorem number 1, you must know it. And you must know it in 2 different ways. I would say number 1, know this. If I give you the center, I give you the chord, and I tell you that this line from the center is perpendicular to chord. Once I say this line is perpendicular, automatically AM become equivalent to MB. So if I tell you that the line is perpendicular, you know that that line bisects the chord. That's the first scenario that I want you to know. The second scenario is this one. If I give you something like this, give you the center, give you the chord, and I tell you that this chord is being bisected, and I tell you that AM is equal to MB, automatically you have to know that this angle here is 90, because this line OM is the line coming from the center. So here I see the line OA. Watch out, look, observe. Level. If this line, if actually we see this line OA, not it is coming from the center. The line OA is coming to the center, and this line OA is going to the chord. What is the name of the chord? The name of the chord is PS. Now they say, prove that this angle here is 90 degrees. And I will say this angle will be 90 once we see that PA is equals to AS, according to the converse of theorem number 1. So if we can prove that PA equals to AS, then the angle OAP is 90 degrees. How do we prove that PA equals to AS? This is a cruel question, believe me. This is a very cruel question. Why? I don't like it as well, because this one might beat you in the exam. If you don't pay attention, it might beat you. Even myself, if I come confused, this kind of a problem will beat me. Why? Because I notice that I have to even construct. Watch out. I'm going to create a line from O to S. I'm constructing a radius. Now, I'm going to prove to you that the triangle OAP is congruent to the triangle OAS. Okay? Once we identify that the two triangles are congruent, we will have corresponding sides that are equal. And the condition that I'm going to use to prove that the triangle OAP is congruent to the triangle OS is this one that says side, angle, side. This is a condition that you can use to prove that two triangles are congruent. It's not the only one. The other ones, it's side, 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 but won't be applicable in this problem. The other one is angle, side, angle. Actually, this is the three that I want you to know accurately. Side, angle, side, 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 angle, side, angle. So here I'm going to use this one. So what I'm saying is that I'm going to look for the corresponding sides that are equal. So I will say OP on a triangle OAP. OP is equals to OS. My reason is equality. that is for my first S. This is for my first S. Now I have to show you the angles that are equal. An angle from the triangle OAP, which is equal to an angle in the triangle OAS. So which angle is equal? Do not forget that this angle O, this side here, is 2y. So let us check, what do we know about this angle O in this triangle SOA? What do we know about O in the triangle OAS? Okay? How do we find this angle? So let's check. Let's check. If we can find this angle, then we are gone. Oh yes. Oh yes. We notice that, but I want to actually show you that the angle POQ is 2y and the angle QOS is 2y. How can I prove this is the angle? Oh yes. Wow. Oh yes. If you look at this angle, yeah, this can be tricky. This is the angle at the center. And this angle at the center, it is twice the one at the circumference. Remember, I said angle at the center and the angle at the circumference must be subtended by the same chord, or maybe you can say the same arc. So if we look at what subtends the angle O here, it's a line coming from Q and S. So we say line from Q, line from S, they meet at this angle O. So we look for another angle which is also subtended by QS, which is angle. You can even go for R. Let me go for R. Is this angle there going there? So these are the angles, both they are subtended by QS, O and R. So we say O, angle O, this angle O, it is twice angle R. So O is 2y. So the angle O is 2y. So that is why now I'm going to say, okay, the angle O in this triangle OPA. So I will put O in the middle to show what my, or yes, it's still in OAP, but I will put O in the middle. I will say I will say POA is this 2y here, and say it's equals to AOS. They are all equal to 2y. What is the reason? Why is angle AOS 2y? Angle at the center, you can say AOS is twice R. Angle at the center is twice the one at the circumference. So now this one is met. Sorry, bless me. Okay, guys. Now let's go back to those two triangles. OA is common. If you look at the triangle AP, let me erase everything actually so that you can see. Remember, here there is a line which has been constructed. If you look at these two triangles, OA is common. So we say OA equals to OA. This is a common side. It is a side which is found in both these two triangles. Now you say, therefore, the triangle OAP is congruent to OAS. And according to the congruency theorems, we know that the corresponding sides of congruent triangles are equal. So it means automatically PA now is equals to AS. The reason is corresponding sides of congruent triangles are equal. I'm ready to write corresponding sides of congruent triangle are equal. So PA equals to AS. Now, because PA equals to AS, therefore OAP is 90 degrees. Reason, this is the converse of a theorem. A line drawn from the center of a circle perpendicular to chord bisect the chord. Lazy to write theorem number 1. A line drawn perpendicular from the center of a circle to the chord bisect the chord. Hopefully, this lesson has been very useful in improving your Euclidean geometry. 10.2.5 was a bit of a cruel question, but I'm hoping you will grasp it. All the best with your maths grade 12. Keep practicing. From me, see you next time. Watch out for the next video where I'll be looking at the other questions. I don't want to make the video too long, so let me just stop with question 10. I will do question 11 separately. Thank you. See you next.